Hi everyone, welcome back to my YouTube channel, that is Tech Stack Learning. Today we are diving into the fascinating world of generative models, a crucial area in artificial intelligence and the ML. So basically that enables us to create new data that mimics existing data sets, right? So I hope you have gone through the previous slide which gave a previous video which talks about the overview of the generative AI and what are the concepts it has. So from generating realistic images to creating music and even text, generative models have opened up a realm of possibilities. So in this video, we will explore three main types of generative models, that is generative adversarial network, variational autoencoders, and diffusion model. And we will break down how each model works, their strengths and weakness, and where are these applicable. Okay, whether you are a seasoned AI expert or just starting your journey in the ML, this tutorial will provide a valuable insights into these powerful technologies. So if you are excited to learn how these models can be transformed, the way we generate the content and tackle complex problems, make sure to hit the subscribe button, like and thumbs up. Let's get started. Okay, so let's start with basically what is generative models, right? So basically those are the class of statistical models basically designed to generate new data points based on the underlying distribution of a given data set. This means they can create new instances that mimic the characteristics of the data they were trained on, so allowing for innovative data creation. That is the basic concept of this generative models. Okay, now on to the data generation. Like unlike traditional model that merely classify or label existing data, generative model focus on creating new data that closely resembles the training data. So this is a feature which opens up a realm of possibilities, like from generating the realistic images to synthesizing text or even composing music, right? So that is one of the key thing. Another one is learning objective. Like generative models differ significantly from discriminative models. While discriminative models aim to predict a label for a given input, generative models delve deeper. Like they learn the intricate patterns and structures within the training data, enabling them to replicate and generate similar outputs effectively. Okay, so at the core of this model, as I said, it is a statistical basis. Like they employ statistical methods to understand and represent the data distribution, which is essential for generating a coherent and meaningful new sample. So this foundation allows them to capture the essence of the data they learn from. Okay, and it is diverse. So generative models actually boost the diverse applications across various domains, like from creating stunning visuals and synthesizing natural language text to generating music and enhancing virtual reality experience. Like they are like vast and continuously expanding. Okay, and lastly, it's like latent space representation. Like many generative models encode input data into the latent space. This abstraction facilitates manipulations, allowing for the generation for a novel data instances. So by navigating this latent space, we can create entirely new variations of the data, opening the door to endless creative potential. So these are the basic characteristics, or what we can call it as what is generative models. So now let's see what are the key characteristics it has, right? As I already have explained in the previous slide, but then here, data generation, latent representation, and learning from the unlabeled data, right? So these are the very key concepts of these models, like data generation. So they can produce new samples from the learned data distribution, so that the data what we have fed in, allowing them to create realistic instances of the data. Like for example, it can generate images, it can generate text, it can generate audio. That is the data generation concept. The next is latent representation. So Many generative models encode input data into the latent space, as I told, where the data can be manipulated and transformed into a like a newly generated instances. That is what the latent representation, which is the key thing here. Okay, learning from the unlabeled data, like they can learn from unlabeled data, which is especially valuable in scenarios where labeled data is very less or expensive to obtain. So that is why it is very good to have this learning from the unlabeled data. Okay, so now let's see what are the types of generative models we have, right? The first one is GAN, nothing but generative adversarial network. Second one is variational autoencoders. Third one is diffusion models, and the last one is autoregressive models. So, what is a generative adversarial network, right? This is nothing but we will use two competing neural networks, a generator and the discriminator, to create realistic data. This is the first like high level overview of what is generative adversarial network, and I will be having a detailed session on each of these models in the upcoming sessions. So for now, I'm just going to give you the overview of what are this model does. So as I said, it uses two neural networks, that is generator and the discriminator, to create the realistic data. Variational autoencoders, basically it learn a probabilistic representation of the input data and can generate new data points by sampling from the learned distribution. That is where the variation autoencoder talks about. Then diffusion models generate data by gradually denoising a random noise signal, basically, yeah, refining it into a coherent output. That is the key thing of diffusion models. And the last one, autoregressive models, generate data one step at a time, where each step depends on the previous one, such as like wavenet, right? You guys would have heard about it. So these are the four models, and I will give you a detailed session of each model with all the examples in the upcoming sessions. Okay. Okay. Okay, so now let's see what is this GANs, and what are the strengths and weaknesses, and what are the use cases it has. Okay, as I told, it consists of two neural networks, generator and discriminator, that actually compete each other. Whereas generator actually creates the fake data, while the discriminator evaluates its authenticity. So that is how this GAN works. And what are the strengths of this GANs, right? Produces high quality realistic data outputs like images, audios, then effective in generating diverse examples, can capture complex data distributions. So like complex data it can generate. This is the main strength of the GANs. Whereas weakness, it could be like training can be unstable and requires like careful tuning of hyperparameters. That is one of the things which we have to consider. Then mode collapse. The generator may produce a limited variety of outputs, so failing to capture the full data distributions. Then sensitive to the architecture of both networks, right? This could be the mild weakness on this GANs. And Coming to the use cases which we can talk about is image generation. So as you all know, then video generation and prediction, data augmentation for training and machine learning models, then style transfer applications like transferring style from one image to another. So now let's see what is variational autoencoding, what its strength and challenges and the use case associated with that. So as I said, VAs are probabilistic models that encode input data into a latent space and then decode it back to reconstruct the input. This is how it works. And the strengths of it's like provides a meaningful latent space that allows for interpolation and exploration of the data, more stable and easier to train the GANs, then can generate diverse outputs while maintaining a reasonable quality. And coming to the challenges, it could be like generated samples may lack detail compared to like GANs. The trade-off between the reconstruction quality and the quality of the generated samples can lead to blurry output. Okay, that requires careful tuning of the KL divergence term to balance between the reconstruction loss and the latent space regulation. And the use cases are like image denoising and in painting. Then comes generating new data points from the learned distributions. Then semi-supervised learning, anomaly detection in data. So, coming to the diffusion models, it's like generating the data by reversing the gradual noising process, right? So, they progressively refine data from a noisy version to a clear versions over the multiple steps. So, the strengths here, like it can provide high quality and diverse samples. It can more stable during the training compared to GANs. It can provide is capable of modeling complex distribution effectively. And challenges could be typically slower to generate samples due to iterative denoising process, requires a large number of diffusion steps for high quality results, and then computationally intensive, like basically it is intensive process, right? And the use cases could be image synthesis, like generating art or realistic images, text to image generations, then audio synthesis, generative tasks in like chemistry or in any other field, right? So coming to the autoregressive models, they are type of generative model used for modeling time series data and sequential data. So these models generate data points by predicting the next value in the sequence based on previous value. So the term, as you know, the autoregressive indicates that model regresses the output variable on its own previous values, so capturing the dependencies and the structure in the data. So coming to the like strengths of this model: sequential data handling. So excellent for modeling sequential data due to their ability to capture dependency between successive elements. Simplicity, like the concept is relatively straightforward, making implementation easier. Then it is flexible, like can be applied to various data types including text, time series, and audio, which is very versatile. Then high interpretability, like often easier to interpret due to the explicit nature of their autoregressive nature. And coming to the challenges, it could be computationally intensive. Training and inference can be like resource intensive, slow for long sequences, right? The limited context, like traditional may struggle with long range dependency analyze, we enhance the mechanism. Modeling bias, like prone to bias from previous output, which can lead to compounded errors in the generated sequence, and slow generations. And the use cases are like NLPs. Then we have time series forecasting, speech recognition, music generation, image generation. So this is all about the autoregressive models. Um, so thank you for listening to me as we explore the fascinating world of generative models. We have delved into what generative models are, how they work, and the incredible potential and they hold for creating a new data. To recap, generative models are statistic models that learn the underlying distribution of the data set, enabling them to generate new similar data points. And we have gone through the different types of generative models like GANs, variation autoencoders, autoregressive models, diffusion models. So as we move forward in the field of artificial intelligence, the impact of generative models will only continue to grow, allowing for innovations we are just beginning to imagine. So if you found this video insightful, please give it a thumbs up, subscribe to our channel, and hit the notification bell to stay updated on our future content. We have plenty more exciting topics coming your way. Thanks for watching, and let's keep pushing the boundaries of creativity and technology together.